So a rock is thrown horizontally from a hill at 80 meters per second. So we've thrown horizontally at 80 meters per second. Find horizontal and vertical velocity. So first thing we are going to do is I'm going to write out, I'm going to draw a picture. So we have a rock. It's being thrown from a hill. Horizontally, you have to know theta is equal to 0 degrees. That's very important. You also know gravity is negative 9.81 meters per second squared, which is your acceleration in the y direction. It also says at 80 meters per second. So that is going to be our VI. I could have wrote it up here, but I have it both places now. So now I'm going to transfer it over to my givens. We have VI is 80 meters per second. We have theta is 0 degrees. We have AY is negative 9.81 meters per second squared. Our unknown, it is asking for the horizontal and vertical velocities. Okay? Because it's asking for a velocity, we have to look for capital V's. So we are going to look for velocity in the horizontal. Okay? That is going to be Vx. It also says at 27 seconds. So I need to add 27 seconds. It does give us a time. I kind of ran out of room. I kind of do that. So we have Vx that we're looking for. We're also looking for the vertical. So this is going to be Vyf. The reason why I don't write an F on the X is Vx never changes. So it's going to be the same initially as it is finally. For our equation, I'm going to look at the only equation that has Vx in it. Vx equals Vi cosine theta. So we're just going to take that 80 meters per second times cosine of 0 degrees, which if you remember, cosine of 0 is 1. So for Vx, we are just going to get 80 meters per second. So that's one of our answers. For Vyf, we are going to have more than one option. Look, we have no Vyfs, no Vyf, Vyf, Vyf. So we have these two equations, doesn't have Vyf. So it's between these two. So if we look at it, we're trying to find Vyf. We have Vi, we have sine theta, we have A. We do not have Y. So if we need to, we might be able to solve for Y, but for right now, I'm going to go on to the next equation. We're looking for Vyf. We have Vi sine theta. We also have A, and we have T. So we can do that equation. Also, very important to know, horizontal motion, when theta is 0, sine theta, sine of 0 is 0. So this is going to cancel out anyway. That's important for you guys to remember that. So my equation is going to be Vyf equals Vi sine theta plus AT. So I'm going to do 80 meters per second times sine of 0 degrees, which remember is 0. So this is going to cancel out. Then we're going to plug in our gravity, negative 9.81 meters per second squared, times our time. So we're going to multiply these two numbers to get our Vyf. Notice, it is going to give you a negative number because it is going down. So we will have negative 343, just kidding. We'll have negative 264.87 meters per second. So that is Vx and Vyf. We are done with part A. Part B, it's asking for find velocity. So we are looking for V after 35 seconds. So our time changes. I'm going to just get rid of this. I'm going to put 35 seconds. That way it doesn't mess us up. So part B, we are going to solve for velocity. Does it tell you horizontal or vertical? No. So what that means is we are going to solve for the resultant velocity. So what that means is we are going to find the x and y components. We're going to find Vx and Vyf at 35 seconds, and then we are going to use Pythagorean theorem. So, to do this, I'm going to do the same equation, to solve for Vx. So we'll have Vx equals Vi cosine theta. Is it going to change? No. So we're going to have 80 meters per second. That is our Vx. For Vyf, we are going to do this same equation. For t, we are now going to use 35. If you plug in 35, you should now get the negative 343.35 meters per second. Now that we have both of those, what we're going to do is we're going to make a triangle. I'm going to go the bigger number first. Remember, negatives don't matter. That just tells us direction. So I'm going to go in the y direction first to draw my triangle. So I'm going to go down, because it's negative, and then I'm going to go to the right. And so I'm going to put our values here. So this is our y value, so I'm going to put 343.35 meters per second. And then I'm going to put 80 meters per second on the x-axis. I'm going to close our triangle. Notice I started here. This is where theta goes. We're going to do a squared. So a squared plus b squared equals c squared. That is going to get us our velocity initial. That's what we're solving for. To get theta, I use inverse tangent. So I'm going to do tan negative 1 is opposite over adjacent. So it's going to be 80 meters per second divided by 343.35 meters per second. These two values, what you should get for VI, you should get 352.55 meters per second at 13.12 degrees, and it would be going down. So that tells us direction. So that's part B. For part C, it says find displacement after 35 seconds. So what we're going to do is we're going to find displacement. When it says displacement, it's not talking about horizontal displacement or vertical. It's actually talking about that resultant again. So guess what? We're going to find the x and y of the triangle. So we're actually going to find x and y, and then we're going to make a triangle. So the only equation that has x in it is this x equals vi cosine theta t. So this is an equation we have to use. X equals vi cosine theta t. Notice we have time, we have vi, and we have theta, right? So we're just going to plug that in. That's going to give us an x value of 2,800 meters. Now we're going to find our y value. Okay? So I'm going to look at our y equations. We have two of them that have y in it. These are the only two that have y. We have y equals, we have vi, we have sine theta, we have t, plus 1/2 a, and we have t. I'm going to use that equation. Also notice this vi sine theta t will cancel out, just so you know. So I can write out that equation, y equals vi sine theta t plus 1/2 at squared. This is going to get me a y value of negative 6,008.6 meters. Okay? So now what I'm going to have is I'm going to make a triangle with this value, this value. Okay? I'm going to go the bigger number first. Remember, we don't care about negatives. That just tells us direction. So I'm going to go down and then to the right. So our down would be 6,008.6 meters. Our to the right will be 2,800 meters. I'm going to close this. I am going to solve. This is going to be our displacement. This resultant is going to be displacement, and then we need theta as well. So to get resultant, we're going to do a squared plus b squared equals c squared. That should get you, just so you know if the answer is correct, you should get 6,628.97 meters at, for theta, we're going to do inverse tangent, opposite, so 2,800 meters, divided by your adjacent, which is 6,008.6 meters. It should be at 24.99 degrees down. And that's how you do this problem.